Hello. Very good evening, everyone. Very good evening. Welcome back to Sisya Class YouTube channel. So, in the last class of JEE Foundation, we were studying probability, right? Last class on probability chadutna. This class also will continue our topic probability. Today we'll be going and seeing a impact or important topic that is asked in our JEE. So let me introduce myself. This is a topic from probability of Maths Foundation series from Sisya Class. I'm Pawan Yashwant. I'm a maths expert teacher at Sisya Class with 5+ years of experience. I'm a graduate from Visakhapatnam in Geetham University. Right, let's see. First, let us study what are types of events. What is an event? In the previous class, we have studied what a probability is. It's like predicting the chances of something happening. What is sample space? Set of all possible outcomes of a events. No, out of any experiment. What is an event? The favorable or something that you want. When you're tossing a coin, if you want a head, that is a event. Those are event. Now, depending upon events, we have classified events into some types. We have seen this yesterday also, right? We have seen this like, yeah, we have seen a line, right? 0, 1. If it's 0, it's an impossible event. Can you get a number 6 on a dice? You cannot, right? So that's an impossible case. Can you get any number? Any number you can get. You can get any number from 1 to 6. That's 100% possible. You can actually multiply it with 100 to get the percentage also. Now, likely, unlikely, highly likely, highly unlikely. Yesterday we have studied all of it. If it's less than 0.5 or if it's greater than 0.5, we have some things. Now, let us see what an impossible event is. An impossible event is such an event that can never happen and its probability is 0. This is a 0 probability event. Example is getting a 7 on a 6-sided dice. Next is sure or a certain event. It is an event that must happen. It's an event that must happen. When you roll a die or when you pick a card, you'll obviously get a card that is either red or black, right? That's one certain event, right? It is a sure event. Next, coming to simple event. An event that consists of only one specific outcomes from an experiment. It is the most basic possible event. If you want, let's give me an example. When you're tossing, you want to have a head on it when it lands on your hand. That's one simple. Or you're rolling a dice and getting a 3. There is only one probability, right? There is only one probability that you will be getting 3. This would be, you want to get 3 on a dice. What are the favorable number of outcomes? 1 is your favorable number of outcomes because there are 6 and you want 1. That is your 1 upon 6, right? There is only one way for this to happen. So what an impossible event is and what a certain event is. And now we have studied what a simple event is, right? Let's continue. Next is compound. Like we have studied simple. ఇప్పుడు మనం చదువుతాం compound event. Compound event అంటే ఏంటి? An event that consists of 2 or more simple outcomes from an experiment. 2 or more simple outcomes from an experiment. It's called a it's also a combination of simple events. Example is rolling and getting a even number. When you roll a die, right? When you roll a die, it has 6 sides. What are the even numbers? You'll have 2, 4 and 6, right? Those are your outcomes. So this is a compound event where you have multiple simple events. Got it? It's a combination. Next, independent and dependent event. Hope you're understanding it till now, right? Hope you're understanding till now. Let's continue. Independent event. 2 events are independent if the occurrence of one event does not change the probability of the other event occurring. Simple example. You are tossing a coin. Does it, and you are rolling a dice. Does the outcome that you get in tossing a coin affect the number that you're receiving on the dice? You're not, right? You're not. ఇప్పుడు అర్థమైంది కదా, if you're tossing ఒక కాయిన్ ని you're flip చేస్తున్నారు, you're getting head in this flipping and you're rolling a die. In that case మీకు 3 వస్తుంది. So this does not affect the other event or experiment, right? So that is an independent event. It does not change, or event does not change the probability of the other event occurring. Next is dependent, or dependent event. 2 events are dependent if occurrence of one event does change the probability on the other event occurring. Okay, right. Then we can give many examples. I put it. No, you are considering one event that is affecting the another, right? You can call, how can I say, chalo dice వేస్తారు, right? Or let me tell you simple example. you are 100 students uన్నారు మీ దగ్గర. I'll explain this. Yeah, let me explain this with the next topic. Yeah, conditional probability. I'll explain the same example. Chalo, the probability of an event occurring given that the other event has already occurred. That is conditional probability. Probability of an event occurring given that another event has already occurred. It is a conditional probability. Let me give you a better example. Now, she is a girl. She is a little girl. Okay. She has some basket. In that basket, there are some apples. So what is my probability of choosing one apple? What is my probability of choosing one apple? It is what? There is one apple, right? There is one apple. How many total apples? I want my favorable outcomes are 5. Favorable outcomes are 5. 1, 2, 3, 4, 5. And my total outcomes are 10. We have studied this yesterday, right? Probability is nothing but favorable by total. At least theoretical probability talks about it. Now, this is where something changes. What if this girl, she eats this apple? తను ఒక యాపిల్ తినేసింది. What is then the probability? Okay, first you have 5 apples. Then what is your total number of apples? You will have 4 apples, right? 1, 2, 3 and 4. Now, if you check the probability, what is the probability right now? It is nothing but 1, 2, 3 and 4. Your favorable outcomes are 4. Given upon the total number of outcomes are 4 plus this 5. Okay, understood? This is what a conditional probability talks about. Next, I'll give you one more example, don't worry. Event A and event B. These are two different events. A intersection B is basically two events, they have something in common, right? Okay, this is okay, done. Now, formula, coming to this formula. A given B, this is A given B. Okay, A given B is equals to P of A intersection B upon P of B. Let me tell you here. This is the changed, okay? Changed. Okay, to easily explain this, let me take, okay. Now, let us take 1 minute. Okay. You have 100 students. You have 100 students. Okay, you have 100 students. Out of this 100 students, 50 students play football. Now, out of these 100 students, 30 students also play basketball. Now guys, please listen. The concept comes here. If I ask you, what is the probability when you select someone? He plays basketball. What is the probability? Okay, let me tell you. And there is one more condition. Okay, there is one more condition. Some of these people also play football. Okay, understood? Right. How can you do this? Total you have 100. For this, you can easily say 30 by 100. Right, this is 30 by 100. What if I say they play both, right? They play. Now coming to one more thing, football and basketball. If I tell you, you pick a student, the student, he certainly plays football. Then what does your probability become that he plays basketball also? It will be 30 upon 50. Okay, this is one more example. Okay, now let's continue. Coming to our topic for today, Bayes' theorem. Let's talk about Bayes' theorem. It is basically a very important topic for you to learn. It basically talks about, it relates conditional and marginal probabilities of a random event. You have multiple probabilities, or your probability is updating, or your events are updating. Then how would you find your probability? This is the most important concept we'll be studying. Right, let me tell you let me give you an example, okay? Chalo, let's consider a disease. Disease. some disease, corona, anything if you want to. Now, the probability that this affects is 1%, is 1%. 1%. Now, here the question begins, right? Now that, okay, you could say conditions also. If you take a test, and if you receive positive, if you receive a positive, then there is 90% chance that you might have it. 90% chance that you might actually have it. Okay. Now, if you receive a test and if you fail, there is again 5% more that you might have it. Due to the testing error, you could say. Okay, if you fail, you might still have 5%. So, in that case, how would you find out the probability that do you have this or not? So, this is the formula, Nana. P of A given B is given by P of B given A into P of A by P of B. Probability is nothing, it's all probability. Now, let us study each term. Let us study each term in this. Coming to what is, let me start with P of A. What is P of A? It is your initial chance. I told you, right? Out of the whole world population, there is 1% chance that you might have this. You might have the disease. Now, coming to P of A given B, it is called posterior property. It is called posterior property. Let us see the definition first. The probability of event occurring given that event A occurring given that B is true. What does it say? It's an updated chance, an updated chance. Okay, you understood this. P of, it's your updated chance of having the disease. Now coming to P of B given A. P of B given A. It is the likelihood. It's called the likelihood. The probability of event B occurring given that A is true. It's your chance. It's your chance of getting positive. Okay. Now, there is one more, last one, that is P of B. It is your marginal likelihood. It is your marginal likelihood. What does this talk about? What does this talk about? It is the total probability of the event B occurring under all positive condition. It's basically your overall chance of getting the disease. What does it include? It includes both your positive or passing or negative cases also. Okay. Hope you understood this. This is what Bayes' theorem is. It's not, it relates the conditional and marginal probabilities. If you have multiple probabilities of, or your probabilities of events are getting updated, you're getting updates of, then how does the probability change? This Bayes' theorem talks about it. Let's once recall what conditional was. The probability of event occurring given that another event has already occurred. You're just updating, Nana. If, yeah, this was the example, right? There were 100 students. 50 of them play football. 50 of them play football. And out of them, 30 also play basketball. What's the probability that? Let me tell you. 100, 50, right? 50 basketball. Out of this, 30 also play, football. Out of this, 30 also play basketball. Right, what is then the probability of, you pick someone and he plays football and he also plays basketball. Okay, he is saying that if you pick someone, you already know he plays football. then what is the chance that he'll also play basketball? What is this? You have 30 people, right? So it's nothing but the probability gets updated 30 by 50. Okay. Because you know the total number of people playing football are just 50, and out of 50, you know 30 people are playing basketball also. Okay. Base theorem is nothing but an extension. It's nothing but an extension of our conditional probability. Then we have studied this conditional example of a conditional probability, right? Yes, let's continue. Okay. Now let us look at something. Okay, question. Now, two balls are selected at random, one by one, without replacement from a bag containing 4 white. Bag containing 4 white and 6 black balls. If the probability that first selected ball is black, given that second selected ball is also black, is m by n, where GCD, greatest common divisor, m comma n, or you could say the common factors, co-primes, you could say co-primes, is 1. Then m plus n equals 2. So it's basically giving us the probability in the form m by n, where we have to find m by n. If they are not co-primes, we have to reduce them to co-primes, and then finally we have to find the m plus n. Now let us define our question. What is the question? Let E be an event. Second ball selected is what? Black. Now that we wrote that because of the probability that the first ball selected is black, given that second ball selected is also black, is m by n. Second ball selected is also black. That means he is just saying us that second ball is already black. What could be the first ball? What could be the first ball? The first ball would be the event. That it could be white, E2 be the event, it could be black. Okay, let me write E1, E2. Let me first select black. E1 be the event, I'll be getting black. And here I'll be writing white. Now, you understood, right? He's just saying that if the probability that first selected ball is black, given that the second selected ball is also black, there is only two conditions. Either the first ball could be white or first ball could be black. But in this condition, what he's saying, first selected is also black, so we have to consider for this. This is the probability he has given us, right? E1, he has given us E1. We can write this as using this formula. Which one? This one. E be the event, right? P of, what should I write? E1 by E. E1 given E. One second. P of E1 given E is nothing but P of E1 into P of E1 by E. E by E1 by P of E1 you have to again write this, all the probabilities that are present, plus P of E2 to P of E1 by E1. Got it? So what is this? P of E1. What is P of E1? P of is a probability that it will be black. What is the chance that if you take a ball it will be black? It's nothing but 6 upon 10. 6 upon 10. Now, you have already taken 6 upon 10. What could be the next one? E1, right? E1. What is E1? Now, there is one condition or event that's already done. 6 by 10 is done, right? Now, how many balls are left? There are 5 balls left. 5 black balls are left out of 9. Now, you have to replace it with 9. P of E2, does this change? How many balls? 5 by right? Sorry, 4, right? 4 white balls. 4 by 10. Now what should this be? Into same this will be 6 by 9. It's the updated, right? 6 out of 9. Now let me solve this. This will be, okay, 1 second. Okay, this is your question. If I want to solve this, I can do it. This will be 3 by 5 into 5 by 9 by, what is this, 3, same, 3 by 5 into 5 by 9 plus 4 by, I can write this as 2 by 5 into 6 by 9. So finally I will be getting 5 by 5 plus 4. Okay, 5 by 5 plus 4 something I'll be receiving. I can write this as 5 by 9. Understood? After we have put down the solution, like after you have taken one ball black from the initial condition, there were 6, you have picked one, that is 6 by 10, your favorable outcomes. Once you have removed it, you have just been left with 5 balls, right? So that's also done. Now, divided by same condition plus this condition where you have 6 balls out of total 9. Okay. This condition is basically you have 6 black balls, 1 white ball is removed, right? Yeah. Let's continue. So what is the question? So this is m by n. Now the total is given by 5 plus 9, that is 14. Do we have? Yes, we have this option. Understood, right? EB the event, second ball is selected is black. What are the possible events? You could select either black or white. I consider 2 events. First event is if it's black, second event is if it's white. If they told me that in this condition, if the probability that first selected ball is black, or if they ask me if it's white, I would take the complete condition in this. I would get a different answer because the number of white balls and black balls are different. Here the sum would be different. After I've considered this event, I have put on my Bayes theorem and solve this. Chalo, let's continue. 3 urns ABC contains 7 red, 5 black, 7 red, 5 red, 7 black and 6 red, 6 black. Let me take 3 boxes. Let me write how many this has. 7 red, 5 black. This one has 5 red, 5 black. 5 red, 7 black. Finally, this one has 6 red, 6 black. Okay, understood. Now, one of the urn is selected at random and a ball is drawn from it. If the ball drawn is black, then the probability that it is drawn from urn A is okay. So you have 3 bags. 3 bags have this set of balls, red, blue, red and black, red and black, red and black. The number is changing, don't worry. Now, at randomly, this is ABC. At randomly, you are selecting one of the bag. What is the chance that you will select one of this bag? There are 3 bags and randomly you have to select it. The probability that you will selecting one bag is 1 by 3, right? Every bag is 1 by 3. It is 1 by 3. For probability of P of A is 1 by 3. B it's 1 by 3. And C is also 1 by 3. This is the first initial part where you have selected one ball. Now, what is he asking? He is asking that ball is drawn. Okay, the ball drawn is already black. What is the chance that it is being drawn from urn A or bag A? I can directly put on A by E, right? P of A by E. Okay, right. Let me tell you, E is the condition, event that black is drawn. E is the condition that black ball is drawn. Now I can apply P of A by E, P of A into, what is this? What did I write here? P of A into, one second. P of E1 into E by E1, right? So here I'll be writing E by A, right? P of E by A. Okay, now I can add this P of A into P of E by A plus, what should I do? P of B into P of E by B plus P of C into P of E by C. Okay, let me write this neatly. P of C. Okay, this is P. Okay, let me write something like this. Okay, because you want this from first bag, but the total there are 3 bags, right? You could get a black ball, right? Everything you're adding just the black balls from each urn. Each urn you're adding the black balls. So how can I write this? E by B, yeah. What is A? P of A. Probability of A is nothing but every probability is 1 by 3. So I can just write this 1 by 3 by. Here also I can take 1 by 3 as common. P of A is equal to P of B is equal to P of C. I just have to add the remaining part. What is E by A? E by is nothing but event that black is drawn from the first bag. How many black I have? I have 5. What are the total? What is the total? In this I have total 12. This also I have 12. 6 plus this also I have 12. Got it? Yeah. So this is the case. So I'll be dividing with 12. Okay. What is this? Same again. 5 by 12 plus, in the second one I have black, right? Yeah, 7 by 12 plus, how many? This also I have 6 by 12. Okay, now what I can do? I can cancel them out, and this is also I can cancel. I can take the common and I can cancel. So I'll be getting 5 by 5 plus 7 plus 6. So that is nothing but 5 by 6 plus 6 is 13. 13 plus 1, 14. 14 plus 5. Okay, just a second. Yeah, 6 plus 6 is 12. 13. 13 plus 5 is 18. Okay, this is your final probability that, what does it say? The ball drawn is black. Then this is the probability that the drawn ball is from urn A. This is the probability, is 5 upon 18. Understood? It's nothing. We have just considered both 3 cases where we had, in the first case we have 7 red balls, 5 black balls, 5 red balls, 7 black balls, and 6 red balls and 6 black balls. I have considered an event E, which is nothing but you're drawing the black ball. What did he say? He just asked us that the black ball belongs to urn A. For that, I have taken the Bayes theorem and I have applied this. Okay. Now, what did I do? The formula was P of A into E by A1, right? I wanted this. So I would directly multiply it. I have put my formula P of A into E by A plus P of, this is the total number of possibilities available, right? B, you have E by B, and P of E by C. So if I multiply 1 by 3 into 5, 1 by 3 is nothing but the probability of choosing the first bag, because you have to consider that also. No, he is saying that what is the he is only asking what is the probability that the bag you have chosen is urn A. So you have to consider every probability. P of B, it's nothing. P of A, P of B, P of C are nothing but 1 upon 3. That's like 33.33%. Okay, then you have put down your formula, taking every black ball from every bag or urn. Chalo, let's continue. Now, this question has been asked in JEE 2023. The previous question was asked in JEE 2024. Right, let's continue. Okay, one second. Now the question is, bag A contains 3 white balls, 7 red balls. Bag B contains 3 white balls, 2 red balls. Okay. Sorry. Right. Let's continue. Bag A. Bag B. Now, bag A contains 3 white, 7 red. 3 white, 7 red. B contains 3 white, 2 red. Okay, 3 white and 2 red. Now, the probability of drawing the ball from bag A, if the ball drawn is white, the ball drawn, he is asking us, okay, he's saying the bag is also drawn at random and the ball is drawn from it. Okay, both bags, you have to choose one of it. In how many ways? Like, what's the probability of choosing a bag? It's nothing but 1 by 2. This is also 1 by 2. There's 50% chance that you will be taking or choosing this bag, or 50% chance for choosing the B bag. Now, what is he saying? He's asking us the probability of drawing ball from bag A. He wants to consider bag A. If the ball drawn is white, let E be the event. White ball is drawn. Okay, E be the event, white ball is drawn. Now, what can I do? P of A by E I can write, right? P of, because he's asking from the first bag, I can write A by E. So this is nothing but what will it be? What did I write? P of A into P of E by A by, how many I have? P of A, P of same E by A plus P of B, second bag, right? I have considering this also, P of E by B. So this is how I applied this, right? Now I know everything. P of A, what is P of A? Choosing a bag at random in this case, 1 by 2. Now, second is E by A. What is the probability that white ball, right? White ball is he asking? Yes, white ball. I have total 10. In this case, I have 5. So this is how many white? 3, right? I'll write 3. Now, denominator. I can again write 1 by 2 into 3 by 10 positive or plus. This is also 1 by 2. Probability of choosing the second bag is also 1 by 2. Into, what is this condition? E by B. E by B I have how many? 3, right? 3 by 5. 3 by 5. Okay. Now, understood this, right? Now we can cancel them. 1 by 2, 1 by 2, 1 by 2. So I'll be left out with 3 by 10 by 3 by 10 plus 6 by 10. Equivalent fraction. Yeah, I made an equivalent fraction. 3 by 5 into 2 by 2. I can just solve this. This will be around 3 by 9. Okay, this is 1 by 3. Do I have the option? Yes, I have the option. Understood, right? We are just applying the formula we have learned. Probability of choosing bag A, right? That is 1 by 2 for each bags, and he's considering the white, right? He's considering white balls. The number of white balls in bag A is 3. This is also 3, and you just have to calculate what is the probability that white ball is chosen from bag A. So for that we applied the formula P of A by E, where E is the event that drawn ball is white. So I multiplied it P of A, choosing the bag, into E by A, the ball you chosen was white, divided upon the first condition plus the second bag, where the probability of choosing the second bag is 1 by 2 into 3 by 5, where 3 is the total number of white balls from the total number of balls is 5. So I have simplified this. I got 3 by 10 by 3 by 10 plus 6 by 10, equivalent fraction. So I have just added them. I have cancelled the denominators 10, 10, 10. In the end, I left out with 3 by 9. 3 ones are and 3 threes are. Hope you understood this. Okay. Let's go. Now, out of 60% females and 40% male candidates appear in examination. 60% candidates qualify it. The number of females qualifying the exam is twice the number of males qualifying it. A candidate is randomly chosen from the qualified candidates. Okay. He's saying basically in 60%, these 60% people, they are selecting some, they selected a candidate. Now, the probability that the chosen candidate is female. Okay. Please try to understand this question. Out of 60% female and 40% male candidates, let me tell you, 100% is the total number of students appearing for an exam. Okay, 60% female, what does this say? In 100, this also asked in JEE 2022. Okay, in 100, I'm giving you an example. This is not real example. I have 50 boys, 50 girls, 50 girls. What he's saying is 60% of females, 60% of females. What is females? I mean, write G as girls. This is nothing but 60% of 50. It will be 30, right? 30. So that is how you should see. It is not directly 100 to 60. Okay, hope you understood. So it is basically, if you are thinking it to 100, it is 30 females. And in this case, 40, it's nothing but 20%, 40% would be 20 girls. So 20 male people. This is how you should be writing the question. Let us not solve this using a probability. Let us solve this directly with the things that we have learned in the previous classes. In the percentages also we have talked sums like this. So the important condition that I will be considering here is the number of females qualifying the exam is twice the number of males qualifying it. Okay. Number of females is, if I consider this as X. Okay, this is X. Now, what will be female qualifying the exam is twice. No. This is males. This is males. Let me consider this as males. Now, number of females would be how much? It will be twice of X. 2X is the qualifying women. Now, what can I say? The number of females qualifying exam is twice the number of males. You have got this. Now, what is the total number of males and females? You could say this, right? It's nothing but 2X plus 3X. Sorry, 2X plus 1, that is 3X. 2X plus X, that is 3X. This is basically he's talking about qualifying only qualifying. These are the total number of people qualified. Okay. Now he also said that 60% of the candidates qualifying it, right? And 60% of the candidates qualified. This is the total number. You can directly equate that to 3X if I write. Okay. Now what is X equals to? 20. You got it, X is equals to 20. What is X? X is nothing but the number of males. Number of females is 2X. 40. This is the number of females. Now what did they ask? They asked us that the probability that the chosen candidate is female. This is from qualified only. So you can directly take. What is the number of females? So probability is nothing but favorable by total possible outcomes. So what is the favorable? Favorable is nothing but 40 females, total females. This is right, you are selecting a, he's asking what is the probability that you will select a woman. It's nothing but 40. What is the total number of candidates or total numbers of possible outcomes? Is nothing but 60. Got it? If you cancel them, you will be getting 2 upon 3. This is your final answer. 2 upon 3. So this is how we have done it. We didn't use any much of the probabilities that we have learned. We just calculated with the basic thing we have learned in the previous class. That was probability is nothing but number of favorable outcomes upon total outcomes. So, and let me tell you, in questions like this, try to consider the total number of people as 100. Try to consider the total number of people as 100, because you don't have any number, right? There are only 25, 26 students passing the examination or qualifying the examination. If you have everywhere percentages, you can definitely try taking 100 as the total number of candidates. If I can take it, if I can take that, how would I be doing? 100, right? 100. 60% is nothing but 60 students will qualify. 60 students will qualify out of 60%. Now again, I have to solve something for female and total male candidates. Right, in this I have to divide them. So basically this is how you will solve. Again, this is how we have gotten this. 3x is equals to, right, 60. Alright, that's it. This is how you will solve this. Okay, let's revise what we have studied today. Okay, we have studied, simple events, impossible and sure events, lying on 0 and 1, where 0 is the impossible event, 1 is the certain event. And simple events, it consists of basically one specific outcomes, like getting a 3 on a die or a king in a deck of cards. Next we have a compound. Compound is basically, getting more simple outcomes. It's a combination, you could say. More simple outcomes, 2 or more simple outcomes. An example is getting an even number when you roll out a die. Then you have independent events. Their example is, right, we are rolling a die in one hand, you're flipping a coin on the other. Those are basically, they don't have any dependency on each other. There are certain dependent event also. We also talked that in conditional probability. This is the important topic for today. The probability of an event occurring given that another event has already occurred. It is basically updated, right? You are taking taking this example. You had 5 apples, 5 oranges. A kid, she takes out an apple. What is the probability that she has taken the apple? It is 5 by 10, because there are total 5 apples by total number of fruits were 10. Now she ate it. She ate that apple. Then how many apples are left? 1 is gone. Right? You have 4 more apples. So the probability changes to 4 upon 9. The condition, or this is, let me tell you, this is what conditional probability stand. P of A given B is equals to P of A intersection B. That is what we have studied. This is the common part divided by P of B. The changed probability of an event. Next, we have also considered this example. Right, you are picking some friends, some 100 students, 50 of them play football. Out of 50, 30 also play basketball. What is the probability of choosing a player or choosing a candidate that plays basketball if given that he plays football? It's basically 30 upon 50. It's an example. Next, we have Bayes theorem. It basically relates the conditional and marginal probabilities, updating events of random events. Now P of A given B is equal to P of B given A into P of A by P of B. We have studied everything. It's the posterior. A given B is the updated change. B given A is the chance of getting. For this, we have considered the example of disease. I guess I have written this. Yeah, this is, you have 1% chance. When you take a test, there is 90% chance that it is positive. No, I'm sorry. If you are taking a test, you have gotten it positive. There's a 90% chance that it is true. And you have taken a positive test, you have gotten negative. And you got that 5% is it's still false. Basically, taking the test, you have multiple false, right? The medical test false, small false you have. That's the condition you are taken. Even you have gotten positive, you still might not have it. Those are the conditions. So this is what we are talking. P of B given A is the likelihood, basically. It's the chance of getting a positive. What's the chance of getting positive? Out of, in the complete population, 1% population will get this disease. So 1% is this. Then P of A is the prior probability. The initial probability, you could say it 1. It is the chance of getting positive. This is not 1, I'm sorry, this is not 1. This is initially prior probability is the initial one. This is basically after event B occurring given that A is true. Now, finally we have marginal likelihood, that is P of probability of B. It is the probability of the event B occurring under all conditions. Even if you don't have the like even if you're getting a positive but it's not true, but you should consider it if you get the result as positive. Even if it's a fault, you should not take it. So it's basically a combination of complete positive and negative cases. Then we have solved this question, right? We are basically, it's about balls, right? It's about balls containing in a, it's there in a bag, right? You just took the events condition. Finally you found out this m plus n. Okay, yeah, yes guys, that's it. This is something very really easy question we have done today. Now guys, for you I have put up one homework question. It's an easy question. If you please try to do it, this one, this is your homework question. This is a homework question for today. What does it say? A newly constructed bridge may fall down either due to wrong designing or by inferior material used in the construction. The chance that the design is faulty is 10%. The probability that the collapse if the design is faulty is 95%, and that due to bad material is 45. If the bridge collapses, find the chance that it was due to wrong designing. So basically he's saying that the chance that design is faulty, he's saying, I told you, right, 1% the world population might get that disease. This is the same kind of question. So this is what he's saying. There's a 10% chance that the design is faulty, and if the 10% design is really fault or that's a really problem, then there is 95% chance that the building will, the bridge will collapse. Or there is second case, it is due to inferior material selection, like lower grade materials you are using. In that case, there is a 45% chance. Okay, now if the bridge collapses, find the chance that it was due to wrong designing. You have to consider this case, 10%, 95%, and you'll be getting it. So guys, I hope you enjoyed this session. If you enjoyed this session, please like, share and subscribe. And we at Sisya are coming up with new Sisya Elite batch for grades 8th, 9th, 10th, 11th and 12th. A craft that is completely crafted, a course that is completely crafted by the IITians themselves. Now you'll ask me, why should you start early? Why should you start early? Sir, I'm in 8th class, I have 5 more years, 9th class, I have 4 more, right? You have so much time in your hand. So please listen to this. The exam that you're going to write is, every year around 13 to 13.5 lakh people write it, appear it. Now out of those, only 2.5 lakh people go to the advanced level, and merely thousands of them go to the top IITs and IITs. Now you'll ask me, still I get 4 more years, 5 more years, why should I? So now the questions that are asked in the advanced or mains type, the difficult questions that are the rank deciding questions are from conceptual based, and not every question can be solved by a certain formula. When you know the concept, it will be extremely easy for you to derive a formula at that time. So building greater foundation will give you the better score in your examination. So this is a huge competition examination, and it will also give you more time to manage. 2 years of extreme or 1 year of extreme studying is extremely stressful for many students. Starting early will reduce that stress and help you manage the time you have. Then we have critical thinking ability. So the more you practice, the more tests you give, the more concepts you learn, you will develop a better critical thinking ability. And finally, you could feel the real competition among your peers and other people of the country. Then you'll ask me, who will teach this in this foundation course? Since the craft is, since the course is crafted by the IITians, it makes sense for them to teach it. So IITians, the pass outs who are graduated from the IITs of India, will going to teach you in this course. Now they know the journey, they know the personal journey that they have done to clear the examination, and we believe right mentorship also is really helpful. Then we have coming to the syllabus. What are we going to teach you in this IIT JEE foundation course? We will be completing the 11th and 12th complete JEE syllabus from basics to the advanced level. Now you'll ask me, sir, where is this happening? Is this happening live on our YouTube? No, this is happening on our Sisya app, where you will be accessible to live quizzes, live ranking systems and continuous progress tracking. Next we have for doubt resolution. So I have doubts, how can I get it clarified? For that we have our AI 24/7 doubt help, one-on-one mentor sessions. You can also contact your master teacher. And finally we have this amazing feature of AI plus mentor collab. Then coming to self-study, we have daily practice. We will provide you with daily practice problems, digital study materials and daily worksheets. Now coming to the testing or the mastering level, the one before the long leap. We will be conducting you with bi-weekly tests and mock tests and test series so that you can know where you stand at, right? Which concept of you is weaker, we can work on it. Then finally coming up to the prizes. For 8th, 9th and 10th, we have 39,999, 44,999, 49,999. If you want to study longer for a longer duration, we have multi-class packages also for 8 plus 8, 9th and 10th for 89,999, 9th and 10th for 65,999. 10th, 11th and 12th is of 2 lakh rupees, but the seats are empty. There are no seats left. Sorry, the seats are empty. Yeah, so there is 100% seats filled. There are no empty seats. For this also, we all have around 19 to 18% seats left. I have to check. Now, until this JEE Foundation series is live in our YouTube channel, you'll be exposed to a special offer. For 8th, 9th and 10th, you'll be around 14,999, 15,999 and 16,999. Coming to multi-class packages, 8th, 9th and 10th for 39,999, 9th and 10th for 30,999. Hope you had a great session, guys. Please let's meet in the next session where you'll be learning more foundation concepts. And please download the Sisya app from both Play Store and App Store or scan this QR code. Right. Hope you enjoyed this session. Please do like, share and subscribe, guys. Have a great day. Bye.